In this example, it says let f of x equal x squared minus 1. Find and simplify. So part A is f of x minus 2, and B is f of x minus 2 minus f of 3. So for part A, it says f of x minus 2. So one thing that can be kind of confusing is that the function in the problem, it's f of x, and in this one it's f of x minus 2. Now this x here is not the same as the x here. So if that's something that throws you off, just think about what f of x equals x squared minus 1 is telling you. It's saying that here x is the input. X is the input, and the output, why is it doing this? To get the output, you take the input and you square it, and then you subtract 1. So I'm actually just going to rewrite f of x equals x squared minus 1 as f of input equals the input squared minus 1. Well, in this case, our input is x minus 2, right? We're reading the function notation f of whatever, the thing is the input. So in this case, x minus 2 is my input. And we know what f does to the input. You square it and then subtract 1. So f evaluated at x minus 2 is equal to x minus 2 in parentheses squared minus 1. Because that's what I get when I substitute x minus 2 in for the input. Okay, now we need to distribute this. So x minus 2 in parentheses squared, x squared minus 4x plus 4, and then minus 1. So you get x squared minus 4x plus 3. Okay, part B says f of x minus 2 minus f of 3. Well, we actually calculated f of x minus 2 in part A, so we know that this is equal to x squared minus 4x plus 3 minus f of 3. Well, what's f of 3? F of 3 is what you get when you plug in 3 into the function. So we get 3 squared minus 1. And I have to put parentheses because I'm subtracting the whole thing. I'm subtracting this difference. So this is going to be x squared minus 4x plus 3 minus 3 squared minus 1 is 8. And then I have a 3 minus 8. So I get x squared minus 4x minus 5. And that's the answer.